indicate to you in a minute. Okay, I might make a start here. Can you hear me at the back there? Okay, cool. Okay, some of you may have figured out that I'm not quite Grant Mooney. My name, in fact, is Robin Bhagia. Grant's a colleague of mine, and he is currently out of action because he fell on his wrist and broke it. That happened a few days back, and he was in surgery yesterday to get some pins inserted into his arm. So I wasn't planning to be here, as you can see, but I will take the class tonight and hopefully make some sense of the material. I teach in several project management subjects around the place, some of those that you are not allowed to do because you're doing this one. My background is fairly varied. I joined the university 15 or so years back. Before that, I was the chief engineer at Boeing, and my role was to act on. My role was on very large defense aerospace projects, and so I've seen some really large projects and kind of have had experiences with both good project managers and people that I would rather have shot. So, what do? You deal with what you get. You can't pick and choose people you work with unless you pay them. But if you're part of a team, you've got to make it work. You guys may be doing a group project here. I don't know how Grant exactly runs the assignments here. But if you're doing a group project, generally speaking, you get to pick your own group members. And that's a luxury you generally don't have when you're out there working. Okay? You work with people you have. You work with other people in other companies that you get. You certainly can't pick and choose people in their companies. Right? So we try to make do. What we do in subjects like this is point some of these things out, and at least then you are aware that when you get out there, you will be confronting these sorts of things and have some wherewithal, some ideas, some skills, some knowledge to be able to deal with them. Okay? And if you think about your group projects, even though you get to pick your group members, things don't always work out very well in those groups. Right? In fact, there are some student groups which are really groups from hell, and you work with them. What do? Right? They do good work, but the group synergy is not the best. Now, when that happens, one of the first things that tends to suffer is the quality of your project's deliverables. Remember, we're doing a project which is to say that we're dealing with something which has got large, or at least some uniqueness about it. And that uniqueness gives rise to risks. Okay. Those risks pertain to cost, quality, time, reputation, what have you. Okay. And so at least one of the risks can be mitigated if we keep our eye on the quality of the deliverables that we're supposed to hand over to the client along the way and at the end of the day. Right? So tonight, we're talking about quality on projects. We will see how quality is understood on projects and what are some of the key ingredients that we're going to look at to ensure that our focus on quality is right throughout the project. If there's anything that you should take away from here, it's this. You can't add quality at the end. You've got to build it right through. Okay? If you produce garbage, it's hard to turn it into something useful at the end of the day, unless you spend a ton of money and lose all your reputation so that no one will ever do business with you again. No business wants to do that. And so we worry about quality right through. Right through. Now, before I commence the material proper, are there any questions from the last lecture that Grant took here that I can help you with? Don't ask me questions about what do I do with this assignment, because I haven't got a clue. That is up to Grant. Hopefully he'll be back next week, and he can answer your questions a lot better than I can in that regard. So I can't authorize extensions and things like that, but if there's any content issues, perhaps I can help. Okay. Okay. Is there any issue like that? Okay. So quality. We will define quality. What is it? How do you understand the term quality? How do you define quality? You often go to shops and buy stuff and say, this is really poor quality. We use this term, like lots of terms, very readily. How do we define it? How do you understand it? Any idea?
The way it looks and feels.
The way it looks and feels? If it looks nice, feels nice, it's good quality? Sometimes. Anybody else?
How likely it is to fall to pieces?
How likely it is to fall to pieces? Okay. Anybody else? So if it looks nice, feels nice, and robustly built, is high quality? Yeah.
Something's ability to perform its role.
Yeah, that might be important. Right? If I give you a very robust, nice-looking bicycle, and your specification said car, doesn't quite make it, right? It's a great bicycle, but a lousy car. So the idea about quality in terms of projects is, in a way, very, very straightforward. Give the customer what was asked for, what was agreed to. No more and no less. It's just the getting there that's the hard part, okay? And so most of the lecture tonight is about what do we need to do to assure that we get there. And when we get there, at the end of the day, we've delivered the client what they wanted. No more and no less. You can't deliver more because someone's got to pay for it, and you can't deliver less because you end up in court. Right? So it's got to be just right. How do we know we are there? How do we know we are there? That's part of the exercise tonight, to try to figure out what are we doing in quality. You guys are dealing with software. I'm not a software engineer. I'm what they call a system engineer. So if I need software built, I go and get software guys like you and say, hey, build me some software. Okay. But every project I've worked on, bar none, okay, and I've been at this game, I was at this game for a long, long time, involved software. Some in really early days, and we used to basically say to ourselves, if it involves software, this project's going to be a disaster, okay, by definition. There was a whole period there where we declared a software crisis, okay, where we just didn't know how to do this. And there were some basic issues here. One thing is that if I'm bending a metal, I can see the thing and say, yeah, it's been bent enough. I can't see software. I can't touch software. The only time I figure it out is when someone tests it for me or when I use it and it doesn't work. There was a time back there when people were figuring out how to remove all the so-called bugs out of software, and it became harder and harder and harder. No amount of testing guaranteed that all the bugs will be out. And so they started to talk about things like this. In a bit of software which is this long, it's okay to have these many bugs because it's average, it's normal, right? It was never okay to have bugs. What made it okay? Well, because we can't do much about it. Right? Life has come a long way since then, I hope, in the world of software. But now the problem is that we're demanding systems which are more and more complex. We want more functionality, more automation, more instant access to everything. Okay? Even the humble mobile phone, which actually started as a phone, but is never these days used as a phone. We use it for everything else except making phone calls. Right? Look at what it can do. This thing here has got more power than when I started building a submarine, the computers inside the submarine had. Okay? It was just crazy. You know, I look at this thing, And I say, if I had that power back then, life would have been easy. With a lot of technology has come a lot of added desires that we have. We demand more and more stuff. We demand more and more features. We demand more and more complexity. Instant access. If your computer doesn't respond in 5 milliseconds, this stupid thing is not working. Right? So the demands on quality have suddenly gone up as well. Right? So while we can do lots of things, we can't necessarily guarantee quality. Okay? So tonight's lecture is about that. Okay? You have talked a fair bit about planning, I hope. And according to PMBOK, you would have seen there are many knowledge areas which require to be planned. We need to plan the management of the scope of the project. What do you understand by the term scope? Where would I find the expression of scope? People at the back, feel free to contribute. Business requirements, yeah. Captured where? In a requirements document somewhere. Perhaps through some WBS somewhere. Right? That tells us what we have to do on this project. So in a sense, it captures the quality. Not just what this thing is supposed to do, but how well it is supposed to do that. Right? And how reliable is it supposed to be. Right? So those kind of things all fall into this scope area. We have to plan the management of time. Okay? No point being ready for the opening of the Olympic Games a week after the Olympic Games started. Right? We need to get there on time. Quality. Cost. Okay? The thing is that none of those is independent of each other. You try to achieve quality, it's going to cost you. You try to manage cost, it's going to affect your time. You try to manage time, again, it's going to cost you. Okay? All that together affect your scope. And the scope obviously affects the rest of it. The more you want, the more time it's going to take. The more you want, the more it's going to cost. Right? So all of those are interrelated. That's what leads to complexity. You can't just deal with one thing. You've got to deal with everything together. So when we teach these topics, we take them one at a time. But rest assured that your plan should be such that it is prepared to handle these things all at once. Okay? So quality management is one of the key elements identified in almost every project management methodology that I've come across. Nobody ignores quality. Okay? It's an area we plan for. On large projects of the sort that I worked on, even though the company had its quality department for overall management of the quality in the company, each major project had their own quality group. Biggest one I worked on, the quality group was about 27 people. That's a lot of people. Right? So, quality management affects every aspect of our work. Okay? Affects every aspect of our work. It almost forms a constraint on the way we do our job, in a way. Okay? Feel free to stop me and ask questions as we go. I tend to ramble on quite a bit, so stop me if you need to ask me questions. I asked you before what quality meant, and we got certain definitions there. On ISO 9000, one of the first standards that came out, ISO, International Standards Organization, the ISO 9000 standard was one of the first ones that came out which tried to establish the definitions and the requirements for quality work in general. And they define quality as a degree to which the inherent characteristics of whatever it is that you're dealing with fulfills the requirements of that thing. No more and no less. Okay? They define requirements as expectations, perhaps of your clients, perhaps of yourself, perhaps. Remember, the clients are not just out there, there are clients inside your company as well. So your boss expects certain quality of work, your project manager expects certain quality of work, Your client certainly expects a certain quality of work. So you've got multiple stakeholders there. Okay? Whatever the requirements are, whatever the expectations are. The only difference is that there must be an agreement that we will build it to these requirements. Okay? Now, we'll talk about agile systems later, where the requirements aren't very well known, in which case the agreement is framed differently. But it still gets to the point where we're saying, okay, we will define as we go what the proper requirements ought to be. Okay? The idea of quality has been sort of evolving as time goes by. In the days of yore, when we used to build products by hand, right, artisans almost, right, then expertise was what you needed to define whether or not something has achieved the required quality. A painter, a sculptor, a guy who makes watches, they would know what a good watch would look like, what a good painting would look like, what a good sculpture would look like. Okay? The thing is, though, each of those artifacts were, in a sense, unique. Even though this guy makes watches by hand, each watch is unique. And we relied on that intuition that that person has, that experience that person has, to judge whether or not something is of good quality. Okay. Then, along came Blanc, who basically said, I can make non-unique parts which you can put together to make stuff. Muskets, in this case, right? And so then, the idea of manufacturing really took off. Okay? So rather than one unique part at a time, I'm building these multiple parts which can be plugged together to create stuff. Now, you don't have to be an artisan to build certain things. You have to know how to process these little parts, and you can build stuff. Okay? Then came Henry Ford and created the assembly line. So not only can we build many, many parts and glue them together, but we can standardize the way things work. We can standardize the way things are produced, and he introduced the idea of mass production. Okay? Idea of mass production. Cars, Ford cars. Right? Then the statistical process as we understand it today start to be thought about. Shewhart introduces statistical control processes, which were used to figure out, hey, what are the various causes of things going wrong, and so we could fix them. Deming then came along, working in Japan after the war, and helped them revolutionize the way they did business. There was a time when I was young when the word was, if it's made in Japan, it's garbage. Right? We used to say basically, oh, something bad broke yesterday, must have been made in Japan. These days, after Deming, after Japan got its act together, Japanese stuff is expensive now because it's good. Okay? What happened from there to here? The idea of quality got taken up through work of people like Deming and Crosby and people like that. Okay? Deming came up and said, here are the 14 points. He came up with these 14 points of quality. Right? Bang, 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 bang. You need to worry about these things, these 14 things, if you want to create quality products, he said. Some readings that Grant has given you, like the textbook by Machuca and people like that, will talk about those 14 points more. Okay. Then TQM was born, 1982, around circa 1982, Total Quality Management. And this was a process where people got trained to avoid waste, basically. And the statistical process controls were used more effectively, perhaps, were added to, and they were core tools of quality control, and we used that to ensure that there was no waste. The idea was to emphasize the elimination of wasteful work. Okay. So you get it right the first time. No rework. No rework. Got refined with the Six Sigma process, and these days everyone talks about Six Sigma, but you can see it kicked off around 86 So it's not last week stuff. But these days, Six Sigma, you get trained in it, you get various belts, green belt, black belt, what have you, indicating levels of expertise that you might have in that process. Okay. This ISO 9000 standard was published in 1987. And then along came ISO 9001, soon following right on top of that, which basically outline the processes to be followed to assure quality. Okay, the first 9000 essentially defined the very basic terminology that we would adopt for quality and elements of quality. The 9001 emphasized the process of how you do these things. Okay. So, quick recap of where it came from. Recall in your project the three key constraints of projects: cost, quality, and time. We are supposed to deliver the right scope at the right time for the right budget. Okay. And there's a trade-off that always goes on in there. And there are risks associated with each of those elements. Okay. Each of those elements. Delivering scope, can we do it? Do we have the skills? Do we have the wherewithal? Do we have sufficient time? Do we have sufficient budget? Okay. If you don't have enough, you're dealing with risk. That scope, remember the definition of project, creating something new with a start and a finish. So it's got a life cycle. Right? So we're managing risks along the way in all of those aspects. The risks of scope are what quality is about. Okay? We're trying to make sure that we deliver what was asked for, no more, no less. Meet every requirement to the extent that it needs to be met. Don't meet even a single extra requirement. Make sure you meet no less than what was asked for, which kind of puts a different onus on you to make sure that you know what the requirements are, what the expectations are. In agile situations, there are more expectations than hard and fast requirements. That's why we do it in a lean and agile way. Perhaps we don't know what's needed until we try something. Perhaps the requirements are evolving as we go. So, expectations and requirements. That's what quality is about. Meet what was argued for, what was asked for, what was agreed to. Okay. Okay. As I said, that we talk about quality on projects primarily because projects involving software are very, very difficult. Okay. Very, very difficult. The software by itself, at least my view, doesn't do anything. It works with other stuff. It needs some hardware, it needs some other processors, it needs some other people so that it can enable other systems to do their job. So in that sense, it's always embedded in a larger system. And so to figure out whether something is working to requirements or not, oftentimes cannot be judged until the end. And by then, it's too late. It's too expensive to fix things. So we need to figure out ways of handling any possible problems early in the piece. Okay? And so the notion of quality control, quality assurance right through the project is essential. You will find very few systems these days, you know, even civil engineering systems these days are full of software. Okay? Your lifts are controlled by software. Your lighting is controlled by software. Your air conditioning is controlled by software. Everything. Your cars, right? Give it a few more years and you will be controlled by software. Right? So when they start doing that, putting software elements in you better make sure that someone's tested it. Okay. You can't touch software, you can't see software. So to some extent we are groping in the dark. We need indirect measures to figure out whether or not we're getting there. Right? So that was one of the issues in one of the projects that I was involved with. I was involved with, as I said, defense aerospace projects. And we needed to check out some software for some weapon system we were building. And in those days, the modeling capability wasn't quite what it is today. And so we prototyped, we tried it out, okay, and we found that, hey, instead of going this way, it made a right turn somewhere and went and hit something else. Not good. But so many people years of work had already gone down building it this way. And you're starting again almost. Right? I'm not saying that we never tested anything along the way, but our tests were obviously inadequate. So the quality lessons have been learned along the way by projects that failed. Okay? The software crisis I talked about before, it gave rise to the whole Software Engineering Institute over at Carnegie Mellon. When we didn't know how to build software to the best of our ability, they created, the US DoD created a Software Engineering Institute at Carnegie Mellon University. And it was headed by a guy, would you believe, called John Goodenough. Okay? So you get a guy who's called Goodenough and put him in charge of something that you want the best possible. Right? But Goodenough did a good enough job, and he created this thing called the capability maturity model, which you may have talked about with Grant. And that was a start of the maturity of software development. Right? Lots of good work was done after that. But we're still not there yet. Why quality within project management? The Standish Group and others create all kinds of reports over time where they collect useful information about whether projects are working or abandoned or nobody cares or things like that. You can see in this few statistics I've got here, back in '94, successful projects comprised 16% of all that were done in those years, of the type of project that they measure, mostly software projects. Okay. 31% failed, and 53% got challenged as to their goodness. And when you challenge a software project as to goodness, you're challenging it as to quality. Right? Things have improved in terms of successful projects. 39% these days are successful. 39% is still less than 50%. Right? So most still failed. 2012. It would have improved a bit by now, except for the fact that we're now demanding more and more complex things. Right? Number of failed projects went down, and the challenge projects went down. What changed between '94 and 2012 is the emphasis on good quality work. That's what changed, okay, in a phenomenal way.
Sorry. Could you explain, please, what does the challenge mean in that context? It's like something went wrong?
Something went wrong, or wasn't doing what it was supposed to do, or not built to the right quality. Okay. Some aspect, some requirement was deemed unmet, or not met well enough. Okay. Yeah.
Could it also just be where the project sponsor is just like, I don't want to pay for that?
Sometimes that happens. Sometimes that happens. But that's why your contract kind of...
Yeah, but would that still, like, even though it's been deemed successful?
No, because it's not... If you build something for me, and I come to you and say, yeah, it's no good, I'm not going to pay. Right? You can challenge that now. Some independent authority will come and look and say, yeah, this person's met all the requirements.
And so then it will be deemed successful.
Correct.
So there's some kind of higher body that's going green light.
Yeah. You see what tends to happen often. Okay, I can talk from my background. Grant has more worked in the IT industry. I worked on systems which has hardware, software, all sorts of things. So when we tested our system, units, segments, subsystems, if you like, we test them to their own requirements, and they pass. Now, when you plug things together, the entire system might not work. Even though the requirements have been met, when you take them out there in the field, it is shown to be really not fit for purpose. Okay? So not built quite the way it should be, for whatever reason. 9 times out of 10, you work back and you find you got the requirements wrong. Okay? But if it's not fit for purpose, no one's going to use it. But if I built to the requirements, I can't be challenged on that. If we got the requirements wrong, well, hey, Mr. Client, you signed off on those. You know how you use the system better than I do. So we should have talked more. Right? But Do you really want to have that argument with the client that you know you've got? My clients were defense clients. If I have that argument with the defense client, there's only one defense client. And if he doesn't do business with me, I go broke. Right? So you want to have these arguments up front, where people aren't quite the enemies of each other. Yeah. But you have, for things you do for other people, you generally have contracts. For things you do within the organization, you generally don't have contracts except informal ones. The internal ones can be more vicious because there's no external reputation to lose. Right? So what you need to do, in my view, is that for my internal projects, I'd be even more cautious getting things pinned down as to the expectations at least. Right? Or a way identified that, hey, maybe you guys don't have the requirements clear and so we can't pin them down, so let's do it in an agile fashion and we'll see how we go. But in that case, you don't know, I don't know, we're moving along. Right? So you figure out a different way of doing business, basically. Very important. It's a good question, that one. Yeah. Okay. If you manage your quality, I guess the lesson here is basically that to not be challenged and to have a successful project, you should manage the quality of what you're doing. Okay? Not just the quality of what you're producing, but the quality of the way you're going about producing that work. Okay? There is a long-standing philosophy which resulted in the idea of costs of quality and so on. But basically we're saying that, if you pick up problems early in the life cycle, they are far cheaper to fix than when you pick them up later. Okay? You will see all sorts of statistics in all kinds of software engineering books which says if you take out the requirements errors up front, every dollar you spend taking a requirement error out in the requirements phase, right, will turn into 10, 12 times that amount later on, and perhaps more towards the end. In fact, Barry Bain found that, if you correct at the early phases, you will catch them at requirement phase, $1, catch them at coding 10 times, catch them at maintenance 100 times. Because you've done so much work, it has to be undone and then redone. Right? Simple as that. And if you've actually talking about maintenance times, you are now talking about the fact that this thing is working in conjunction with other things that the business has. So if you have errors to fix here, you're not just affecting the item at hand, you're affecting every other item that this thing is working with. And so it's an entire business exercise. So it becomes important to catch problems early in the phase. Okay? Those of you who are doing software engineering and subjects like that will have come across this idea many, many times, I'm sure. Okay? As I said, you got those three things: scope, time, cost, and then quality. Orthogonal to that. Achieving quality doesn't come free. There was a definition of the costs of quality. There were three elements at the time. Grant has grouped them together here. One was the cost of appraising, going and finding problems. One was the cost of preventing problems from getting into there in the first place. And the third was the cost of repair. Okay. Grant has grouped the cost of appraisal and the cost of repair in cost of defects, which is fine. Okay. But you can see the sorts of things that you do. You have to plan for preventing issues going in. You have to train your people up, better skill them. Right? You have to monitor and manage the quality process. Right? You have to create maybe specialist units of staff, quality assurance people. You have to go and audit. You have to go and then create plans and execute those plans and ensure that the plans are in control and what have you. All that costs you money, but it all helps preventing errors from occurring. So those are called the costs of prevention. Cost of defects, well, you're going to have to go find the problems. That's going to cost you. You're going to have to go and redo the work. That's going to cost you. Sometimes it can't be rescued, so you chuck it out. Right? All those different costs that you have over there. There could be risk to life and property, think Challenger. Okay? Think Challenger. So all those things are costs of defects. And if you go and look at the statistics for these things, you will find that by far this outweighs the cost of prevention many, many times. Many, many times. And so it pays to invest a bit in cost of prevention. All of us want quality, but getting an agreement on what it means and how to go about it can be tricky. And so you find most companies involved with projects will have a broad-brushed policy which says quality means this in this organization, and this is how we will do quality work. And then you're going to take that broad-brush policy and create plans and strategies out of that which suit the project at hand. Okay? You may have a broad-brush process for the entire company, but that might not be suitable for this particular project. Every broad-brushed policy and plan needs to be tailored to a specific project. So we need to ensure that we do that. That tailoring is often indicated via the project quality plan. PQP stands for Project Quality Plan. Our tailoring of company's process, that tailoring gets affected by two things. One is what it is we're trying to do, the size of the project. Okay, the company policy is this big and the project is this big, you're not going to apply the whole lot. Too wasteful. But it will also be driven by the client and what their needs are. It will be driven by the laws of the land. You can't disobey the law, however much it will be cheaper not to do so. So your project quality plan captures all that. Okay? Captures all that. And then project quality management is about creating this project quality plan and working that plan and ensuring that there's a control mechanism in place to help us with the variations that might occur. Okay. It must exist, a quality plan, and every member of your project, every project team must understand not only the words of the plan, but the intent of what those words mean. Okay? So there must be a clear understanding of this is what we're doing. Okay? Having said that, if everybody is responsible for quality, which is true, you will find that no one's responsible for it, because everyone thinks it's the other guy's business. So what we also do is we choose some person, put an X on their forehead and say, you are responsible for ensuring this plan works. Typically, that person will be called a quality manager. Okay? One of the least enviable jobs of all. Okay? Has anybody here been involved in your workplace? A lot of you work with quality aspects of projects or whatever it is you guys do? What are some of the quality aspects, say, of a McDonald's? What sort of things would they worry about? Food? Food that doesn't kill? Instantly, at least. Huh? Sorry? Cleanliness, yeah? And
The food that's hot enough.
food's hot enough? Okay.
The food tastes everywhere the same. in any
Tastes
country.
everywhere the same, yeah?
Country.
Yeah? Yeah?
Looks as well as taste.
Yeah, looks as well as taste. And the way that the people deal with you when you go there, right? the smile should be just this wide, no more, right? And if you think about it, somewhere in the background there, someone's counting what's the wait time for people here, okay? How fast are we processing? There was one restaurant chain which counted on people waiting, okay? Sizzler. They actually made an assessment that it's okay to have 30 people wait 30 minutes. Okay, and it worked for them. Didn't work in Australia, but it worked very well. It's still working over there over in the States. You go out there, you're guaranteed to queue up. Okay. Then when you get your chance, you feel so happy. Okay. My turn. Okay. If you think about your projects, it's like any other function, if you like. It takes certain inputs, transforms them in some ways, and checks out some outputs. Okay? We can check for quality at each of those points. Okay? We can check quality at the input. We can check quality of the process. We can check quality of the outputs. We need to make sure that the inputs that are going into whatever it is we're doing are high quality. If it's people with good skills, let's go get them. If it's raw materials, if it's tools, if it's software to stimulate and simulate environments, let's go get it. The right inputs. No matter how good your process is, garbage in, garbage out. Okay? But you can put first-rate inputs, but if your process sucks, well then that's not going to do you much good either. So you need to check the quality of the process against the standards that were set for that process. Okay? Then, given a good set of inputs and a good process, even then, at some times, you'll produce something which is not up to scratch. So you need to test the output as well for quality. Okay? The inputs, process, and the outputs. From inputs to process, if you like, is generally termed assuring quality. Okay? Ensuring the right inputs go in, ensuring the right processes are occurring. That's trying to assure quality. When you start to examine the outputs against the standards, now the work's done. So you're trying to ensure the quality control now. Okay? You're controlling the quality through sampling or some such mechanism. So that's basically the overlay of quality management on the project management process. Okay? Or indeed any process. Okay? So what we're doing here is not unique to projects. The ideas of quality and how to manage them apply across the board to whatever it is we're doing. If it's not quality, it may be operations. Okay? If it's not operations, it may be services. But the ideas of managing quality are very, very similar. Okay? So typically, we plan our quality effort. These are the key steps of quality management. Okay? And these have been defined in the PMBOK body of knowledge, project management body of knowledge, constructed by the Project Management Institute. And they say that the three key steps are plan it, do it, and while you're doing it, make sure you're following the plan. So assure quality, and then control quality. Okay? Control quality. So quality planning determines what standards we will use to measure ourselves. What are the requirements? What level of goodness is required? Okay, that sort of stuff. Okay? So we select what targets we will go for. We select how we will measure. We select who will do all this work. What process will be used. How often do we check? So all that gets captured in your plan. Okay. Quality assurance then, as the project unfolds, it starts to monitor. Okay. Looks to ensure inputs are good, looks to ensure process is good. Okay. And control is measuring the specific outputs that we need to ensure. Okay. Compare the outputs of your quality assurance activities with the standards that were defined in the plan, and take corrective actions. So those are the three aspects: plan, process, and then effectiveness. Measure it. Measure it. A lot of people talk about quality on projects. Some people, I have heard project managers who say that the work of quality is done as soon as the project quality plan has been built. Now that we've done that part, let's get on with the work. Okay? Doesn't quite do the trick. Planning, quality policy for the project may be there. It may be a distillation of the company policy for quality. Okay? But then you need somehow to implement that policy. The implementation process is captured in the quality plan. Okay? As I said before, that plan will tailor, or as Grant says, adjust the overall policy to the specific project. Okay? And I can't emphasize how important that is. Okay? There's no such thing as a generic plan that applies everywhere. It doesn't work. Describes how the quality of the project will be assured, levies all the appropriate responsibilities and such. Okay? These things that we do require additional work. The client wants this much done to this level of quality. We have to go and ensure that. The client doesn't care about the ensuring of it. So your work breakdown structure may say, I've got to do all these things to build this. But on top of that is the management of quality. So extra activities, extra time to do all this work. And that needs to be reflected in the budget of the project. Okay? So when you're planning your project is when you're planning the quality of the project as well and how you will do it. Okay? I said before that it's driven through a risk mitigation attitude. Okay? As an example, there may be a process area such as project requirements here. Okay? How to identify, collect, clean up, and capture the requirements. Okay? Documentation. And the kinds of measures we will use, maybe customer acceptance and sign-off of the traceability of requirements. Customer sign-off of the final requirements document. Okay? And how would we judge that? We will have the requirements analyst present traceability to the customer. Okay? Review by customer and sign-off by customer. Has that happened? If the customer hasn't signed off on the requirements or the traceability, well, then our job's not done. Okay? So, as an example of planning, this is a typical template that gets used. Templates get more and more sophisticated on larger projects, but this is at least what you need. What is the area? What will be the measures? And how will we evaluate them? Okay? How will we evaluate them? Now, the point down below there says this review area might be pertaining to the entire project or some part of it, okay? Assurance, quality assurance. So quality planning, first step. Second step, quality assurance. These are activities that we do to meet our standards, basically. Our plan says these are the quality standards we're going to meet. What are the activities that do that? Okay. Here, quality audits come into their own. Audits are things we do to go and see if we are doing things the way we promised. So your plan says this is how we'll do the work, and audit will go and judge, are you doing it that way? Okay. And here, it's not just, yeah, we've done that. You need evidence. Okay? You need evidence. Not evidence that was manufactured last week. Evidence of constant work right through. Okay? Otherwise, it doesn't work. Okay? The focus on these audits is to improve our process. Okay? Is to improve our process. Make it more efficient, make it more effective. Okay? Audits are not there to find people to blame. Okay? We're not doing a witch hunt. We're looking, yeah, we're doing a witch hunt, but for problems, not for people. Okay? When we find the problem, we then go figure out how to make sure it doesn't happen again. That's the idea. Typical template that gets used, again, the same process area. A standard could be analysts have completely assured, have completely captured the software requirements. Okay? How would you judge that? Through peer reviews, perhaps. Okay? That's the activity. Do peer reviews. Peer reviews take time. Peer reviews cost money. Right? How often? In the early days of requirements work, perhaps weekly. Later on, perhaps quarterly. Okay? And a person is made responsible. Okay? And there are other examples there. But you use some kind of template like this. The key difference here, from plan to here, is you have identified the interval and you've identified the responsible person. Okay. Third step is quality control. So up till now, we've identified the standards and we've tried to make sure that the standards are met. Now we're looking for defects. Looking for defects. Okay. So we look at the project results every step of the way and say, are we getting the right results to the right level of standard of quality? Many, many tools have been proposed. Pareto analysis, the so-called 80-20 rule, which in this context basically says 80% of your problems will be caused by 20% of things. So we home in on root cause analysis and identify what exactly is causing the issues. Total quality management people came up with this thing called the cause and effect diagram, the Ishikawa diagram. Very good way to capture the root causes of some problems. Okay? And we can do fault tree analysis, we can do all sorts of things to figure out what might be the 20% that's causing us the problem. We do statistical sampling, check a sample of outputs to see if it's okay, check a sample of requirements if they're complete and good and all sorts of things, right? Quality control charts, these are called run charts and what have you. These are charts we draw of the process, of the way we are doing things. In our case, the software development process, the project process perhaps. Okay? And we check to see how often does the project go offline and go crazy. Right? Helps us improve the process. Okay? We do inspections. We do benchmark comparisons. How are we doing against some defined benchmark? Okay? How far apart are we? Okay? Walkthroughs, the developer literally walks other people, other experts through line by line of design and code. And the basic idea is that we pick errors out, okay, by doing that. This walkthrough and inspections of software were some of the key elements that came out of the software crisis. These were attempts to find problems early rather than late. Okay. We do audits, and we try to create a mindset of continuous improvement. So these are some of the tools that we are armed with for statistical analysis and just looking to see what the hell is going on in terms of quality. Okay. The quality control outputs, as we say, is, yep, this thing is good, or no, this thing is not good. Acceptable, not acceptable. Not acceptable either gets chucked out or reworked, either of which is costing you big money. Okay. And for process, obviously, the control charts, run charts, these tell us how to improve our process. Okay. So given good inputs, good outputs can come out. Are there any questions? Is anybody still awake? Any comments? Abuse? I take everything. Okay, cool. A possible template. You can see now we're dealing with requirements documents still in the same process area, but the finance clients might have different requirements. HR people may have different requirements. Administration people may have different requirements. And it's not just a gross set of requirements that needs to be verified. We need to find the right stakeholder to look at the right requirements. Okay? And they need to be involved in this. The control activity, get hold of the finance group, get hold of requirements experts in there, or they can hire some requirements experts to help them, get them to do a quality check, review, okay, and sign off. Okay. Other groups do similar things. And then the project manager needs to sign off on needs to ensure sign off of the complete requirements. Okay. Your analyst of finance group's requirements will get the sign off there. HR group analyst will get the sign off there. Total project responsibility rests with the project manager. Rests with the project manager. Given all your learning about project management, how many of you would like to become project managers? Yeah? Yeah? Why? Interesting? Can boss people around? Why would you like to be a project manager?
I don't know. Seems like fun.
Sounds like fun? Having worked on some large projects, I can tell you, I wear the scars, okay, of managing projects. Some of them are still bleeding, okay. But I can also tell you that working on projects gives you a high like almost nothing can. It is fun, but it can get very, very bad at times. When you get home and your dog barks at you and bites you because you've been away for the last 6 months and nobody recognizes your kid's grown up by that time, things are getting bad. Right? It's fun when everything is going well. It's exciting when things start to go bad, but you can recover it. Right? But when it comes time when you're looking for at the seek.com to see where's the next job that I can go to, then it becomes tricky. Try it out, it's good fun. It is. Okay. You learn a lot, you learn a lot. You're always dealing with risk by definition. Quality control. Okay. So, because we can't see software, oftentimes you find people saying things like, yeah, we can only check this thing out at the end. Okay. At the end is almost too late. Right? You need to check right through. The whole process needs to be checked out. Okay. We focus on the process of the development of software. That's where the trick lies. That's where the difficulties are. That's what we don't know how to do very well. And so we home in on that. Okay. Then you'll be better off. Testing is what we normally do to look for bugs and to see if something's gone wrong. Okay. And there's two kinds of testing, if you like. One is called validation. One is called verification. Verification checks to see that you've met all the requirements, okay, such as they were. In other words, you built the system correctly. Okay. Validation checks to see that your system is fit for purpose. In other words, you've built the correct system. Okay. So verification, have we built it right? Validation, have we built the right thing? Okay. Both are crucial. Some people would know of validation as commissioning of your artifacts, right? Commissioning. Are we building the product right? Validation, are we building the right product? Building the product right requires your requirements traceability, testing that each requirement has been met, and testing that each requirement has been met just so. Okay. I must be able to sell off every single requirement. Validation is about the black box. This system I've created, does it do what it's supposed to do? When I press the green button, does the light come on? Okay. And can I actually use this without killing anybody? Right? That sort of stuff. Will it work in this environment in which it's supposed to work? Okay. Generally speaking, total validation happens at the end. But we have to validate along the way. Okay. We may start off with a very vaguely defined need of some client. Okay. Then we take that vaguely defined need and we create a set of requirements that we will work to. I'm assuming you can do that here. I'm not talking about agile systems here, okay? And we can do that. Before we launch off and start creating a system based on those requirements, we should make sure that they're the right requirements. That is to say, when I build to them, a right system will result. So your requirements sign off and your requirements work that you're doing, the validation of the requirements document, that's a validation process. Okay? If I build to these requirements, I will end up with the right system. So why do we do it at the end again? Because as you do your projects, things change. Things change. Requirements change. Need changes. Clients' expectations might change. Yeah, all that needs to be managed, but things do change. Definition of a project again. And so, we validate again at the end. Okay? In waterfall type of situations, if you look at it, all along the way, you're verifying before proceeding to the next stage. Okay? Is the analysis in accordance with the requirements? Is the design in accordance with the analysis? Is the coding according to the design? And so on and so forth. Okay? At the end, we test and implement. That's acceptance testing. Acceptance testing at the end. And if that's the only place you're doing validation, you could be in for a big surprise. Okay? Most experienced project managers will tell you that the requirements need to be validated before you move on. Okay? Any questions? It is quite late in the evening. I get it. Okay. Oftentimes you find that this thing called V&V, verification and validation, we get an independent person to come and do it. These kinds of people are called IV&V agents, independent verification validation agents. They specialize in these sorts of things. And the reason we use them is that you can get an impartial view of whether or not a system is verified okay and validated okay. Okay. Agile systems offer a slightly different worldview to us because the client is there on site. Okay? And so whatever misunderstandings we have, we can get them checked. We do double paired programming practices. So we can check stuff as we go. Right? Continuous integration through all those cycles that you have, right? Which is a variation of verify, 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 validate. You're validating as you go, pretty much. Okay? Early and often testing, of acceptance testing. Whole game plan behind Agile. And so there's some differences that arise. Okay? Activities occur much earlier, verification and validation, than they do in Waterfall. You know, there was when Waterfall was first invented, we basically saw the client at the beginning, where they came and gave us a need, and we saw them at the end when we finished doing it. Okay? In the middle, we classified ourselves as the expert who needs the client. So the only time we find out that, hey, we misunderstood the client was at the end, which is one of the reasons why Waterfall didn't quite work very well. Okay? Works well when you have rock-solid set of requirements. Rarely do we have that. So frequency of activity is greater, verify and validate activities. Fewer static quality assurance techniques because by the nature of the game, you're changing your product's evolving as we go. So you can't just say, I'm going to test for this thing and that's it. Okay? So you have an evolving quality assurance practice as well. Okay? Quite nice for situations which require agile methods. Okay. Okay. You will find that each company, each organization will impact the way in which all projects are done, and particularly how quality is affected. The organizational culture, the organizational attitude, the organizational worldview will affect the way you handle quality. Okay. Some research has been done. You find that, within the organization, from group to group, there may be 21% of variation in the way in which things work in terms of quality processes. Between organizations, though, there's a huge variation. Okay? Huge variation. Organizations really affect the way in which you do businesses. So what we're trying to get to is an organization which supports quality work. You know? And simple things like good, clean workspace dedicated to programming, for example, works wonders on programming projects. Okay? If you have a hot desk, come in the morning, you may have this desk or that desk, depending on how late you come in. Leads to poor programming habits. People just not used to working in the environment. Okay? So these are sorts of things that are not in the control of the programmer. These are in the control of the organization itself. So unless there's a quality attitude right up top, this one really trickles down. Bad attitude trickles down to bad attitude down below. Okay? And if you've worked in an organization, you'll very quickly see what kind of attitude your management has. You clearly see if they're just paying lip service to what's supposed to be done versus work from the heart. Okay? Very easy to see. So, to conclude, quality means different things to different people, even though we define it in one way. On projects, we said that the requirements drive your quality, and we gave some differences there with the agile projects because your requirements evolve, right? So we measure it differently, right? But the key thing that I'd like to emphasize here is that this is not something you do at the end. Let's see how it works out, and then we'll add quality back in. Very, very expensive if you adopt that game plan. Okay? Continuous improvement, incremental improvement, way to go. Experience tells us. Okay? At the end of the day, it's the client who judges whether something is of quality or not. Okay? We can think that we've done the best we can, and yet the client's not happy. Okay? And it's the client's project, it's the client's product. Any questions? I believe that Grant hits you with some quick quiz. Does he give you marks for these? Nah.
No.
Does he make you do them?
No, just the homework.
Homework? Okay. So let's just do that. Do number 6 there. What's validation? What's the difference between verification and validation?
Validation is something whether it's correct or not.
Oh, okay. Keep going.
That's it.
That's it? Okay. Validation is whether we've built the correct system.
That's all.
Is it fit for purpose?
Yeah.
Verification is about whether we have built it correctly. Have we met the requirements? So verification is about requirements. Have we met them? Validation is more about, are the requirements good enough? Okay? Whether the right requirements in the first place. Okay. Okay. Rest of them, homework for you guys. And Grant will see you next week. Fingers crossed. Okay. Here are some references. I think the same references as all the lectures. Do you have a textbook here, or just the references?
Just reference.
Yeah. There's so many project management books that you can pick any one of them. Okay. Have a look at that article by DeMarco and Lister. DeMarco was a leading light in the world of software, particularly when we had crises back there. Some of these techniques that you use these days are a result of the works of people like DeMarco. Bit dated, you can see 1985, so it's not recent, but worth reading. We used to have a lot of pain in those days. It's always fun to read other people's pains. Okay, have a good evening.
Thank you. So I just have one question.
Sure.
So when somebody asks you about the projects, it looks like you're not very satisfied with the project management. So you said that you had some scars. Does it mean that you failed some projects in your life?
Oh, we failed big time.
You did fail, seriously.
Big time, yes. In terms of one of the projects that we worked on, mind you, these projects are huge, okay? I'm talking about, you're not talking about millions of dollars, you're talking billions of dollars, okay? Well, over budget, over time, right? Lots of technical issues along the way, right? So you get into trouble. But you fix it,
Okay.
right? You
But
fix
does it
it.
mean that like when you fail some project, then your career would be finished instantly?
No, not on these kinds of projects.
Oh, really?
Once we recovered this project, we were rare people who know how to fix things, right?
Because I remember from the grants, the situation is that when you fail with one project, and then you have like the blacklist history, some companies cannot even sometimes choose you because you have some type of stuff.
It depends upon why you failed. It generally depends upon.
How did you become the project manager